In the last video, we covered 7 operators. So today we'll explain the last one, which is bitwise operators. Hello everyone, this is TechCent. Let's continue with this series on Python. Before we continue, I need to explain the concept of binary. Binary numbers are 0 and 1, and those binary numbers are the language of our computer. That means the computer doesn't understand English or normal numbers like 45 or 12 and so on. What it does is it converts them to binary. Now, why am I talking about binary in this video? Because we will be working with them today. But if you don't know anything about them or how to convert a decimal number to binary, don't worry. I'll be explaining everything you need to know about bitwise operators because we'll be needing binary and you will see why. In Python, we have 6 bitwise operators. First, we have the complement operator. Second is bitwise AND, bitwise OR, XOR, left shift, and right shift. So let's start with the first one, which is the complement. Now, how do we write this complement in Python? So let's say I said print, and we use the symbol that is right underneath the escape key. So it is this form, and then I'm gonna use number 10. What do you think we'll get? Let's see. We got minus 11. But why? Well, first let me explain what is complement. Complement means reversing the binary format of a number. That means complement of 1 is 0 and the complement of 0 is 1. Now let's jump into the whiteboard and explain this concept. We are on the whiteboard and let's convert number 10 to binary. Don't worry, if you don't know how to do it, I have left a link down in the description that will take you to our website that will help you convert decimal to binary. The binary format of 10 is, well, I'm gonna write it in 8 bits, so 0, 0, 0, 1, 0, 1, 0. So this is the binary of 10, or the binary format of 10. Now to find the complement, as I said, we need to reverse 0 to 1 and 1 to 0. So 1, 0, 1, 0, 1, 1, 1, and 1. This is the binary format of minus 11. But how and why? The system never stores negative numbers. It always stores positive numbers, right? It first converts the negative number to positive number, so minus 11 will become 11. Then it finds its binary format of the positive number, of course. In my case, it will be, I'll write it in 8 bits, 0, 0, 0, 1, 0, 1, 1. Then what it will do is, it will find the complement of this binary number. So 0, 0, 1, 0, 1, 1, 1, and 1. Then it will add plus 1 to it. So 1, 0, 1, 0, 1, 1, 1, and 1. What I just said right now is actually a formula to remember. Whenever you want to convert a negative number to binary, first find the binary format of the positive number, then find its complement, then add 1 to it. Those two binary formats are actually same. So that explains why we got minus 11 as an output. Next is bitwise AND. Now we know the illogical AND, which is written in that way, AND, but this bitwise AND is written differently. Using the ampersand symbol, like so, this is called the bitwise AND. So let's say if I said print 10 bitwise AND 11, what do you think we will get? Let's see. We got 10, but why exactly? Before we start, I need to draw for you a table that we will be needing. And this table is special for the AND. So whenever you want to compare two zeros, you will always get 0. Whenever you want to compare 0 and 1, you'll also get 0. Same as if you want 1 and 0, you'll get also 0. But let's say you want to compare 1 and 1, you'll always get 1. So this is the table for AND. I'm gonna write above AND. Now let's start by converting 10 to binary. Earlier I used 8 bits, but this time I will use 4 bits. It's less time consuming. So 1, 0, 1, 0. And then I'm gonna convert 11 to binary, which is 1, 0, 1, and 1. Now let's start by comparing those binary numbers. First we have 0 and 1. As the table tells us, 0 and 1 is equal 0. So we'll get 0. 1 and 1 is 1. 0 and 0 is 0. And 1, 1 is 1. Now wait a minute, we got this same binary format of 10, and that explains why we got 10 as an output. So by comparing the binary numbers following this table, I found the output of my code. Right now let's try the same example but with Bitwise Or. So I'm gonna jump back to PyCharm, and to write the Bitwise Or, you will use the vertical bar symbol. So let me run my program, and we should get 11. And let me explain why. So I'm gonna add a new table, and this one is for the OR. So I'm gonna leave the AND here, and let me start writing the OR. 0 and 0 gives us 0. 0 and 1 gives us 1. 1 and 0 also gives us 1. 1 and 1 also gives us 1. So this is the table for OR. Next to it, I'm gonna convert 10 to binary. So 10 in binary is 1 0 1 0. 11 is 1 0 1 1. And right now let's compare the binary numbers. 0 and 1 is 1. 1 and 1 is 1. 0 0 is of course 0, and 1 and 1 is 1. As you can see, this binary format is same as the 11 binary format. So that explains why we got as an output 11. Next we have XOR, and its symbol is the caret symbol. So if I run my program, we should get 1. Wow, why did we got 1? So let me tell you. As I did for those two, we have another table, but this time it's for XOR. So I'm gonna write it over here. 0 and 0 gives 0, okay? 0 and 1 is 1. 1 and 0 is 1. But 1 and 1 is 0. So this is the table for XOR. As you can see, the tables differ. Right now, we're doing the XOR one, so I'm gonna use this table. And first, let's convert 10 to binary. We already know it, it's 1 0 1 0. Then 11, which is 1 0 1 1. And now let's compare the binary numbers. So 0 and 1 gives us 1. 1 and 1 gives us 0. 0 and 0 is 0. 1 and 1 is also 0. And this is the binary format of number 1. And that explains why we got as an output number 1. So remember, it's all about understanding the concept. I used those tables to compare those binary numbers, and we got the output. Next we have left shift. So to write this left shift, we use double less than sign. So if I print 10, and what I'm gonna mention here is how many bits I want to shift to the left. So I want to shift 2 bits, let's say. And what should we get is 40. But why did we got 40? First, let's convert 10 to binary. We already know it, 1 0 1 0. But we know that in math, an integer has infinite 0 after it. But they're zeros, so we don't mention them, right? So same in binary. Let's say here we have the point, and we have infinite zeros after it. Left shift is you gain bits. So I said I want to shift to the left by 2 bits. That means I'm gonna jump from here to here. What I have now is 1 0 1 0 0 and 0. Let me just delete that. And we got this binary format. Now what is the decimal number of this binary format? Well, we will use the power of 2. First we have 2 0, 2 1, 2 2, 2 5. Now, where we have zeros, I'm not gonna count them. So we have here 0, 0, 0, and 0. We won't count those. Instead, we will calculate 2 5 and 2 3. 2 to the power of 3 is 8. 2 to the power of 5 is 32. If we add 32 and 8, we will get 40. And that, my friend, explains why we got as an output the number 40. What I did first is converted 10 to binary, then left shifted 2 bits, we got 2 zeros, then I converted this binary format using the power of 2 to a decimal number. Now same for right shift, but instead we lose bits using right shift. So let's say I want to right shift 10 2 times, and to write it I'm gonna write 2 greater than signs, and 2. Later we will write this in Python to see what it will give us. So, as we said, with left shift we gain bits, but with right shift we lose bits. So 1 0 1 0, as we said, we will lose bits. If I shift to the right 2 times, that means I'm gonna lose 2 bits. And those 2 bits are gone, and we are left with this binary format, which is 1 0. And 1 0 is the binary format of number 2. How do I know that? Let me use the power of 2 to prove it to you. So 2 0 here, 2 1 here. We don't count the zeros, so we will get 2 to the power of 1, which is 2, and it is the binary format of number 2. So to write the right shift, we use double greater than sign. Let me run my program, and we got 2. Alright, this is it for Bitwise Operators. Thank you so much for watching today's video. This is TechCent, and see you in the next one.